Hello, this is Andrew Gonzalez, and this is Lab 2, Lines of Charge. So the introduction, the purpose of this lab is to build off of the floating tape model in Lab 1 and compare the electric force from the point charge that represents the tape model to a line of charges model in Lab 2. To observe the line of charges, we divide the tape into small segments and treat each point as a point charge, rather than the whole tape as one. A computational model was built using GlowScript to replicate the charges on the tape and the objects it interacts with. So let's cover some fundamental principles. Coulomb's law, which is the electric force between two charges or two charged objects, can be described by Coulomb's law, which is given by Fe is equal to K times Q1 times Q2, which is the charge of both objects, over R squared times R hat, where K is the Coulomb constant. Gravitational force describes the attractive force between two objects with mass, which, for example, could be tape versus hand or the tape versus the earth. The last law, which is Newton's second law, can be given by force is equal to mass times acceleration. This principle describes how the force applied on an object and its mass affect acceleration. So let's review some assumptions and errors. The first assumption is that air resistance is considered negligible. This will simplify calculations. The second assumption is that the long tape is calculated as a single point charge. This only applies to lab 1, while in lab 2, we separate the tape into several point charges. The third assumption is that we assume each piece of tape has an equal amount of charge evenly distributed throughout the atom. This can vary due to loss of handling with the human skin. And the last assumption is that each atom occupies an area of 1 times 10 to the negative 20 meters, which is confirmed to be the average length of an atom. Some errors that we encounter are that each piece of tape has the loss of charge due to poor handling, and this is because the human skin is charged electrically and takes in some protons when handling the tape, and also in reality, charge is almost never equally distributed throughout the tape, which we assume here. So these are the lab one results. U tape is created by removing it from the base tape, which charges the U tape, and a neutral piece of tape is then supported by two objects, while the charged U tape is held under, and this tape is point B. We assume we calculated that the length of tape B is 0.221 meters, which means that the tape mass is 0.000221 kilograms. The distance between tapes when tape B started to move was 0.0273 meters or 27.3 centimeters. We calculated that the magnitude of forces on tape B was 2.116 times 10 to the negative 3 newtons, while the magnitude of charges on tape B was 1.067 times 10 to the negative 8 coulombs. So this is my glow script model. The constants and measured values are listed in lines 3 to 12, which are shown on the right. And then the electric field calculations, which were taken from the lab 1 code, are shown in lines 14 to 20. A new addition, which is lines 23 to 36, had the function to create the lines of charge, which were necessary for this lab. We continue by calculating the simulations and calculations of the electric fields and forces, which are given through lines 42 through 65, and then the final calculations are and force vector arrows are given from 65 through the end of the code. This is the glow script output given, and it shows the two lines of charges along with the force vector arrows pointing up, and then the total force vector pointing up, which is the white arrow, which is the electrical field, and then the yellow arrow, which is pointing down, which is the gravitational force. So the discussing. What if you had modeled each of your tapes as a single point charge? This is what we did in lab 1, and the charge was estimated to be 1.067 times 10 to the negative 8 coulombs. And when we were broken into small segments, the lab 2 charge was estimated to be 2.499 times 10 to the negative 8 coulombs, which is more than twice as more. Why do these estimates differ? These estimates may vary because we use different levels of precision to calculate them. So for example, in lab 1, we used 1 point charge, while in lab 2, we used dozens of point charges. The lab 2 line charge model is closer to the real value because it measures smaller segments and becomes more accurate. when compared to lab one. Thank you for watching.